What does that mean? What do you think we're going to do with this density thing? It's got 2 units on it. What do you think we're going to do with it? We're going to do conversions with it, aren't we? This is going to allow us to convert from mass to volume, or from volume back to mass, if we know the density. Okay? Fair enough? Here's what you would do in the lab, excuse me. You put your piece on the balance, and in this case they have 68.60 grams, and then they take it and they determine the volume. How do you think they determine that volume? Why they subtract right there? 45.0 minus 35.5. They took a graduated cylinder, they had 35.5 milliliters of water in it, they put the solid in, and the volume went up, right? The difference is the volume of the solid. So what's the density then? We would take 68.60 grams divided by 9.5 centimeters cubed. Because also 1 milliliter equals 1 centimeter cubed. Okay? We won't need that too often. And that's what they do right here. So it comes out to be 7.2 grams per centimeter cubed. Okay? So if I told you something was 7.2 grams per centimeter cubed, and I said you had 2 cubic centimeters of it, how much mass would you have? You would have 14.4 grams, wouldn't you? By the same token, if I told you you had 21 cubic centimeters, how many grams do you have? Ooh. Can you do that? What if you have 21 cubic centimeters? Or, no, 21 grams. Sorry. If you have 21 grams, how many cubic centimeters do you have? How am I going to use the density now? Now I have to flip it upside down, don't I? 7.2 grams is 1 cubic centimeter, isn't it? Make sense? What's that? 2.9? Roughly 3, right? 2.9 cubic centimeters. See how we're going to use density? Just like we've been using other conversions. Same thing, okay? Can y'all work on this one? Can you solve this? Now you're not trying to do a conversion, you're trying to find the density. You got to use 2 things, mass and volume. Find the density for this object. All right, we need 2 numbers, right?
Yes.
How many grams do we have?
48.0.
48.0. We also need cubic centimeters. How many cubic centimeters do we have? Well, I have milliliters, right? Because remember, milliliters and cubic centimeters are the same thing. I can just change those units out. Okay?
Is it wrong to say that again?
No, it's the same thing. Same thing. You'd ask for grams per cubic centimeter, right? So this one would be better. So what's the answer then? 48 divided by 8 is 6.0 grams per cubic centimeter. Some of you say, but wait a minute, we started with 3 sig figs in each number. I know. But when I subtract these 2, it goes down to 8.0. So we lose a sig fig here. Yeah, we're not going to worry about it here. This is mixing, adding, subtracting with multiplying, dividing. It gets really crazy. Don't worry. It's no 2 sig figs here. Okay? I don't want you to worry about it here. Yes, ma'am. We're going to ask about sig figs?
No, I'm going to ask about the milliliters versus a cubic centimeter.
1 milliliter equals 1 cubic centimeter. So you can use.
Multiplying the 8 from the subtraction by 2?
Do what? I'm sorry, I didn't understand the question. Ask me again.
I know how you got 8 milliliters.
Yeah.
But I'm lost on the cubic centimeter because in the previous example, you did something where you multiplied by 2 to get 14.
Yeah, but we're doing something different here. We're just trying to find the density here. We're not using density to do anything else with yet. We're just trying to define the density. It's a separate problem, right? Now, we could use this density to do other calculations, right? Theoretically, if I told you had something that was 2 cubic centimeters, you would tell me that, oh, it must have a mass of 12 grams, right? Because 1 cubic centimeter is 6 grams. 2 cubic centimeters must be 12 grams, right? Does that make sense? That's the kind of problem we're getting ready to do. Right now, we're just trying to calculate the density. You're going to do this in lab as well, when you do the density lab. Okay? We okay with calculating density a little bit? You get more prep? No? Tell me.
I'm gonna need to come see you after class.
Well, ask me what's going on right here. Just tell me. Let's see if you're probably not the only one. This lady over here is afraid to ask me questions, thinks I'm going to
I
get
may
laughed.
be the only one, but I'm just.
It's okay.
You ain't the only one.
You paid your money, you can ask whatever question you want. Ask.
I don't know what is going on.
You don't know what is going on.
Like, I
Okay?
know how
Amen.
this started out, like I know how to start the problem out, but it's just like, after there,
Okay.
it's over my head.
All right. No, I don't think it is. I think you're just a little lost, a little fuzzy. We're going to get you there. All right. In this problem, it says, what is the density? And so just like we've been doing problems before, it tells me I want an answer that is in grams per centimeter cubed, right? When I look at this problem, I can just mark this out and put centimeters cubed right here. Because milliliters and centimeters cubed are the same thing. Okay? I just get rid of them. Okay? So I know I need to know how many grams and how many centimeters cubed. The units tell me what I want to find, don't they? Well, when I read the problem, it tells me I have 48.0 grams, doesn't it? Okay? So, hey, look, that's like half the problem right there, because we know how many grams. Now we got to figure out how many centimeters cubed this object was. Well, let's look at the picture. If I start off with some water in a graduated cylinder, and I add that object to the water level goes up, right? How much does the water level go up? It goes up the volume of this object, doesn't it? It increases by the volume of that object. That's how much it's going to go up. It has to. Well, how much did it go up from here to here? That's the difference between those two numbers, isn't it? Okay? So that difference is what? 8.0, isn't it? So now all I have to do is divide the two numbers. Okay?
It's like when you do it, it's so easy, but when I do it.
I know. And that's why, listen, here's the analogy I often use for my students, okay? I'll tell you, I'm 48 years old. Been doing this since I was like 14 years old when I first took chemistry, maybe 15, I don't know. I've been doing it over 30 years, okay? So, of course it's gonna look easy to me. Have you been doing anything for 30 years? No, you're not even 30 years old, are you?
No.
Okay? So how are you going to get proficient with this?
Practice.
Practice. And where are you going to practice? Okay, that's where your practice is. Maybe you get into mastering and go, oh, crap, I can't do these. Let me back off. What happens if you get there and you can't do anything to master? Go to the book and look at the odd number problems, or look at the examples in the book. And if you still can't do it, you better come see me. Okay? But yeah, that's how you're going to get better, right? You got to train. I've been training for over 30 years at doing this stuff, right?
There's some good websites too.
There are some good websites. If you Google like density, how do I calculate density? You'll come up with all kinds of stuff. Some of it's crap.
Yes.
Some of it's, like I said on day one, Khan Academy. If you see anything with Khan Academy, it's going to be good. Okay? Take a look at it. Khan Academy, K-A-H-N. All the videos are on YouTube. He has a website, but then when you click on a link, it always takes you to YouTube. So if you go to YouTube and you type in density Khan Academy, I guarantee there's a video for it. Okay? So Google can be your friend to help find stuff. Don't overuse it, because there's too much information out there. If you start to feel like you're getting a little bit more confused, come see me. Email me and say, hey, what time are you available tomorrow? And I'll be like, I might email you that morning, so you better check email in the morning, okay? Probably between 7 and 8. And I'll say, hey, I'll be in my office between 11 and 1 today, or 10 and 1. You're like, I can't come then. I'll be like, well, can you come see me between 3 and 4? Okay, so I'll be there for you, I promise. If you're really that lost.
Oh, shoot, I'm sorry.
Hello.
Apologize.
So it's cool on.
I know.
All right. This is what we just did. So here's a problem applying density now. So now we already know density. Can we apply density? Let's look at this problem. I wish I could get rid of this stuff down here. Let's look at this problem. Let's circle the things that are important here as you read it. John took 2.0 teaspoons. You think that might be important?
Yeah.
It's a number. Let's circle it. Does it matter that it's cough syrup? Well, maybe if you're his mama, but to me it don't matter, okay? The syrup had a density of, that might be important. And there is 5 milliliters in 1 teaspoon. So what is that telling me? It says 5.0 milliliters equals 1 teaspoon. So I rewrote it mathematically. Okay? The rest of that stuff, and then it asked me how many grams. Okay? Let's see if I can remember all this. 2 teaspoons, 1.20 grams per milliliter, and 5 milliliters equals 1 teaspoon. And I want to know grams. These problems are like big puzzles. Okay? I understand. How do you get, anybody here like to put puzzles together?
Mm-hmm. Yeah.
When you were little, did you start off with like the 1,000-piece puzzle? No, you start off with the little cutout shapes of little things on them, right? A little teddy bear goes in a teddy bear shaped slot, right? That's a puzzle. And then you work your way up. Maybe do a 100-piece puzzle. Now you're big, you can do a 1,000-piece puzzle. Might take you a while, right? This problem's a puzzle. You got to see how it fits together. So when I look at this, I go, Well, I look and I see, well, I want my answer in grams, and I got grams in one place. I'm probably going to use that close to the end, because it has grams, right? So I'm not going to worry about that yet. This is an equality, which means I could write 5 mils over 1 teaspoon. Fair enough? This number right here only has 1 unit on it. So what is the most likely number that I will use first?
2.2
teaspoons.
2 teaspoons, 2.0 teaspoons, right? So I'm going to use it first.